Hello guys, welcome to my channel on Tech Chronicle with Swastik. Today I am going to tell about database management system, that is DBMS full course on my channel. So before I will going to start, all of you like, share and subscribe to my channel so that you will get the latest update regarding the course and some other information regarding computer science for upcoming courses. Today in this lecture 17 I will going to tell you about minimal cover and what is the minimal cover with example. In this lecture I will going to tell you about minimal cover, extraneous attributes and canonical cover. Here you will going to learn about minimal cover with example, extraneous attributes with example and canonical cover with example. Now coming to the first one, that is minimal cover. What is minimal cover? A minimal cover of a set of functional dependency F is a minimal set of functional dependency F min that is equivalent to F. There can be many such minimal covers for a set of functional dependencies F. Now coming to the steps to find the minimal cover. First one is split the right hand attributes of all functional dependencies. Let's take an example. A implies xy, implies A implies x and A implies y. Second, remove all redundant functional dependency. Example, A implies B, B implies C, A implies C. Here A implies C is redundant since it can already be achieved using the transitive property. Now coming to the third step, that is find the extraneous attribute and remove it. Example, AB implies C. Either A or B or none can be extraneous. If A closure contain B, then B is extraneous and it can be removed. If B closure contains A, then A is extraneous and it can be removed. Now coming to the example of minimal cover. This is one question given, we have to minimize that in this question. The question is given, that is A implies C, AC implies D, E implies H, E implies AD. First we will going to split all the right hand attributes of all functional dependency. So the step 1 become A implies C, AC implies D, E implies H, E implies A, E implies D. Now in the second we will have to remove the redundant functional dependency. So it become A implies C, AC implies D, E implies H, E implies A. Here the redundant functional dependencies E implies D. Now the third one is we have to find out the extraneous attributes. AC implies D. We have to find the closure of A. So it becomes AC. Therefore C is an extraneous attribute and it is removed. A implies D. So the final minimal cover is equal to A implies C, A implies D, E implies H, E implies A. Now coming to the extraneous attributes. An attributes of functional dependency is said to be extraneous if we can remove it without changing the closure of the set of functional dependency. Now coming to the example of extraneous attributes, let us consider a relation R with schema R A, B, C and set of functional dependency F equal to AB implies C, A implies C. The closure for functional dependency F is F plus. It's become AB implies C, A implies C. In AB implies C, B is extraneous attribute. The reason is there is another FD A implies C, which means when A alone can determine C, the use of B is unnecessary, redundant. Now we can find out the closure for the new set of functional dependencies, which is same as F plus. Closure of a new set equal to new functional dependency same as F plus. Hence we can declare that B is extraneous. Now coming to canonical cover. A canonical cover FC of a set of functional dependencies F such that all the below properties should be satisfied. F is logically implies all dependency in FC. FC logically implies all dependencies in F. No functional dependencies in FC contain an extraneous attribute. Each left side of functional dependencies in FC is unique. There is canonical cover or canonical cover FC of a set of functional dependencies F such that all the below properties should be satisfied. F is logically implies all dependencies in FC. FC logically implies all dependencies in F. No functional dependencies in FC contain an extraneous attribute. Each left side of functional dependencies in FC is unique. That is, there is no two functional dependency. Alpha 1 implies beta 1 and alpha 2 implies beta 2. Is such that alpha 1 implies alpha 2. Now coming to the example of canonical cover, we have to find out the canonical cover of functional dependencies. A implies BC, B implies AC, C implies AB. Now, in this relational schema, if A implies BC, B implies AC, C implies AB, first step we have to create a singleton right hand side dependency. A implies BC will break into A implies B, A implies C. So now the functional dependency will become A implies B, A implies C, B implies A, B implies C, C implies A, C implies B. In the second step, we have to remove extraneous attribute if any exist. So the functional dependency will become F is equal to A implies B, A implies C, B implies A, B implies C, C implies A, C implies B. So there are no extraneous attributes exist. In the step 3, we will remove the redundant functional dependency. If equal to A implies B, A implies C, B implies A, B implies C, C implies A, C implies B. Remove B implies A dependency and we can get A from B through B implies C and C implies A. So now the functional dependency F is equal to A implies B, A implies C, B implies C, C implies A, C implies B. By removing C implies B dependency, we get B from C. Through C implies B and A implies B. So now F is equal to A implies B, B implies C, C implies A implies C. By removing A implies C dependency, we can determine C from A. Through A implies B, B implies C. So now the step 4 will be the final canonical cover is as follows. FC is equal to A implies B, B implies C, C implies A. So A closure will be is equal to BC, B closure is equal to AC, C closure is equal to AB. Thank you. That's all for this lecture. See you in the next lecture.